the CNC machine, CNC system. So as we learned in chapter 1, we said we have the part program, which is a set of instruction that explain to the machine what need to do. Okay, so the programmer will write a set of instruction or a program, and this program will be sent to the machine processing unit, or the CPU of the machine, or the machine control unit. And the machine control unit, it has the software that's required to translate or convert this coding into action that will be sent to the machine tools. In the previous chapter, we learned how to read some important engineering drawings, which will be used in this chapter to write the program. So without the drawings, you cannot write the NC part programming. These are the expected outcome from this chapter. In this chapter, we are going to learn the main format of the program, or the NC program, using the ISO standard or ISO standard format for CNC machines. We are going to learn the difference between the G code and M codes, and how we can write the address, how we can write the block of coding, how we can build a program for NC machines. So these are the main content for these chapters. Okay, so before the programmer to start to build the program for the NC machines, I mean, at the beginning, we said there is some idea for the product, or idea for the object that they want to design or they want to produce. So they do some sketch, some drawings, and these drawings actually they make like the design for the object or for the product that they want to produce. After they make these drawings, they send this drawing from, for example, from the design engineer to the programmer, or to the NC programmer, NC part programmer. So the NC part programmer here need to study all the relevant components for the drawing here. After, means need to apply chapter 3 that we learned. So he will receive the drawings, and from this drawing or from this sketch, he need to read all the dimensions of the product, or the tolerance of the product, or the material that will be used to produce this product, and so on. So all the related information need to extract from the drawing that he will receive from the design section, or from the engineer, from the designer, or the design engineer. Okay. After he receive this drawing and identify all parts of this drawing, he need to identify the type of material that be machines. Okay, so what is the type of material? Is it aluminum? Is it steel? Is it plastic? Is whatever is the type, based on the type that we listed in chapter 3. Then determine the specification and function for the machine to be used. So what is the type of the machine that he needs to use? Do he need to use a milling machine, drilling machine, turning machine, and any type of the machine? So he decide what is the, or if he need to use more than one machine, he need to decide the sequence of this operation. So which one need to use first? Is it the milling or the turning, for example? So after that, he need to decide the dimension and the mode of operation. As we said, we have two type of dimension, or two system for the dimensions or measurements. One is the metric system, and the other one is the using the inch. So if they use metric system, that means all the drawings that he received should has the dimension in metric. That means in millimeter, for example. Otherwise, it should be in inch. I mean, either this system or that system, because all these things need to include in the program that will be developed. Then decide the coordinate system. So is it absolute coordinate or incremental coordinate, as we learned in chapter 2? Okay. So if it's absolute, what will be the program? What will be the coordinates for the different axes? If it's incremental, what will be the coordinate for the different axes? Identify the plane of cutting, for example. Is it XY, XZ, ZY, and so on? What is the plane that he need to use for the coordinate? determine the cutting parameters for the job and combination and the size of the tool that he is going to use. Decide the feed rate for programming. So all these we are going to go through, all these parameters we are going to go through in this chapter. So I mean the one that we already covered in the previous chapter, like coordinates and so on, we are going to see how to include in our program. The one that we didn't talk yet, we are going to give a definition and overview about it. So you will learn how to calculate these values and how to include these values in the program. Okay, then check the tooling requirement, establish the sequence of machining operation, identify whether use of special feature like subroutine, mirror, and so on. All this related to the building or to the structure of the program that the programmer need to build or need to write. Decide the mode of storing the part program once it's complete. So, I mean, these requirements, any programmer need to know about it before he proceed to write the program, after he receive the engineering drawings from the designer engineer. Okay. So these are the main steps actually. The first, he need to read the drawing. He will receive the drawing from the design department, for example. He will receive this drawing that we learn, and he has the block here, the address block of the which include all the information like the material, the tolerance, the type of material that he will use, the date of this drawing, the revision, which revision, which company developed this drawing, everything in the blueprint chapter that we learn, he will find in this drawing when he receives. After he read this drawing, he need to translate and convert this drawing into program. So he need to start to write the program by using the coding. Okay, so as we said, we have the G code and M code. Later we will see some example about it. And the program, it looks like this one. So after he read the drawing, he needs to write the program like this one. And this will be the G code program or the CNC machine program. After he write this program, he need to send this program into the machine control unit or MCU. Okay. So after he has the program, this program will be stored either in the, for example, in the conventional NC machine, they use the tape. So this program will be changed into or will be stored on the tape, and the tape will go through the tape reader, and the machine control unit will understand what is the program. Otherwise, for the current machine or the modern CNC machine, you need to store this program using, for example, pen drive, using CD-ROM, using directly from the hard disk of the computer, and upload to the machine control unit of the NC machine. Okay, so he will take the program, put it in the CNC, the machine control unit. After he sent the program into the machine control unit by using the CPU or processing unit of this or the processor of this MCU, it will translate it and convert it into action. This action will be taken by the machine. So if it's milling machine, turning machine, lathe machine, and so on, so it will be translate the coding into action. So each line of code, for example, it will be convert into sequence of actions, and at the end you are going to receive this product, for example. So for the drawing in the first was the drawing here, which is the top view, the side view, the front view for this product, and then with the dimension and so on. So when they send it to the machine will produce this product according to the material that they will be used, according to the machine that they use to produce such product. So this is the sequence or the flow of the CNC processing, starting from the design part until you have the complete or the finished product. So what is the program here? Since you are computer engineer or electronic and computer engineer, the program can be defined as a sequential of machine instructions. So any program, either in the low-level language or high-level language, always it represents a sequence of instructions or a sequence of commands. So this sequence of instruction and command will be sent to the CPU or to the processing unit or to the control unit, and the control unit or the machine control unit or the computer will understand this sequence of command or instructions. So this instruction here represent the code that contain all information required for the machine or required to machine a part. That means to machine the object, the drill, milling, turning, cutting, whatever. So and then this machine will perform this task according to the instruction listed in the program. CNC code here, or the machine, or the code or the program of CNC here consists of blocks, also called lines. So it is like 1 line, 2 lines, 3 lines. Each line we call it a block. So this block actually include several words, and each word we are going to list the type of word that we are going, word addressing that we are going to use. So same for other language. For example, when you write a program in MATLAB, when you write a program in C++, and so on. So all the programs is consist from lines. Lines consist from some commands, either, for example, if statement, loop, switch, define parameters, define integers, define variables, make a counters, and so on. So this all consists from all the units that we use to build our program. So here in the case of the CNC code or CNC program, the code consists from blocks, and the blocks consist from words. So each word here will be represented, for example, from a number and alphabetic character, like ABC, whatever is the number, I mean, we are going to see later on. So letter with numbers. So for that, they call it numerical control, because it totally depends on numbers and also in addition to letters. So here, CNC codes are listed sequentially. So I means you cannot jump. You cannot go from line 1 to line 5. No, it should be in sequence. Complete line 1, go to line 2. Complete line 2, go to line 3, complete line 3, go to line 4, and so on. So it will work horizontally and then vertically. Horizontally from left to right, so it will read the whole line from left to right, and it will perform or execute all the commands or all the words in this line. Then after finish, it will move to the second line. After finish, move to the third line, and so on. So it should be sequentially in the number block, each movement made before the next one. So if I have some action need to be taken in line 1, so I need to complete this action, need to be complete before to move to line 2, and so on. So this is like a general form of the program that we have for the CNC program, and actually this is applicable for all type of programming language. So, but for the CNC machine here, since we are working with the CNC machine and the CNC code, so the program, if we want to translate or we want to read it as written in the word in English, actually it's not this. This is not a program, but this is like it show you what we need to do in the first line, what we need to do in the second line and third line, and so on. So, for example, in line 1 here, select the cutting tool. So we need to select the type, the cutting tool. Which cutting tool is it? Tool number 1, number 2, number 3, depends on the machine itself and its number of the cutting tool. Then to turn spindle on and select the speed, RPM here. For example, need to turn the spindle on and select the speed. Then rub it to the starting position of the part. Turn coolant on, choose program. I mean, if we want to read the program, it will be like this one. I mean, it consists from lines, and in each line, the machine needs to perform one task or multiple tasks. After the line is finished, move to the next line, and so on. So it depends on what is the task we ask the machine to do. Later on, we will see in details what we need to put in these lines. But if you want to know how to read or what type of the code that we need to put here, the translation of this code or the description or the explanation of this code, it will be like this one. For example, choose the proper feed rate. So for example, we need to define the speed, we need to define the feed rate here, we need to define the cutting, the speed of the spindle, we need to define the coordinates for the product, we need to define the dimensions, we need to define the type of, is it absolute or incremental? We need to define the type of the movement, is it point to point or is it continuous, and so on. All these need to be listed in the program. So if we go to the specific for BART programming, that one in general for the program, but if we go for the NC BART programming here, the program is actually consists from some of the commands to control the data processing unit or the machine control unit of the NC machines. Okay, so it is similar, as we said, similar to the high level language like C++, which tell the CPU of the computer to create a computation job, for example. So the difference between the NC BART programming and the high level language program is this machine, this type of program is directly talk to the machine. For that we call it low level language or low level programming language. It's like assembly that you use in micro B, for example. In the assembly language programming language, we give some commands which is like in hexadecimal and so on, which is directly go to the microprocessor. So the microprocessor can understand. But when you write this command, you don't actually, it's not readable or it's not understood by the human. But there is translation for it. For example, there is some command, this command to start, this command to stop, and so on. But the machine only who is the most one that or the most part which can understand this type of language or the low level language. But for the high level language, it's easy for human to read it or to the programmer to read it. You can read, you can write start, you can write go, for example, for I equal to 1 until I equal to 10, do this job. Then increase the counter, decrease the counter, redefine, sort this type of information and so on. So the programmer, it's easy to understand the high level language. But when you send this program to the CPU need to interpret, or you need to convert this language from high level to low level. So for that, the CPU do this task in order to inform the computer what they need to do or what the computer needs to do according to this high level programming language. So for our programming language here, which is the NC BART programming, is directly talk to the machine. So you are going to write some codes. This code is not readable. It's not understood by, you cannot understood unless you have a list of commands. For example, if I said G00, you cannot understand what G00 means unless you have list what is the G00 means. I say G02, so what we mean by G02. So I have some definition for each command or each code that I'm going to use for the CNC machine. But in the high level language, no need for this one, because I'm going to write the program. I need to define function, I need to define variables and so on. So it's easy for me as a programmer to understand what I write inside the program without any guide, without any list of commands, for example. So the G code format here for the BART programming is consists from, actually we call it G code, and this G code actually is consists of some of the command using the G letter. For that we call it G code. Most of the command inside this language use the letter G. So we have G00, we have G01, G90, G91, G27, 28, and so on. So all these consist from the letter G, and there is some other letter will be used, but the commonly used is G, or the most commonly used are G letters. So there are other, comparing with other language, as we said, it is directly talk with the machine. So it's not like the Fortran, like C, like Pascal, C++, Java, Python, and so on, because this we call it high level language. And this high level language is easy to read and will be interpreted to the by the CPU, convert it into the command for the computer. So the NC part programming here consists of a block, as we said. It's come from block or line. So inside this block we have multiple words, and after they finish this line, we go to the second line, which is also another block and consists from multiple words and so on until the end. So the first one that we have in any program, we call it the sequence number. So for example, if you see some of the code, I mean, you can even find in the internet using it for basic language. This is one of the oldest high-level programming language that used for the computer, for example. So every line you need to write, for example, the first line is 10, 20, 30. So this is the sequence. Then if you have some command here you want to go, you ask, go to 20. So the program will return to this line. Go to 10. Then the program will go to 10. So these numbers here in the beginning of each line, we call it the sequence number for the line, or line sequence number. So in the G code here, or in the NC program, these numbers start with the letter N. So you can see N20, N30, N40, N50. This is the line number or the block number. Okay, since we say this is a block, so this is the block number is 20. This block number is 30. This block number is 40. So it's good to structure your program. So it is easy to move between the program. It's easy to identify the error, to know you have some error in line 20, you have some error in line 30. You need to do amendments to the line 40 and so on. So they use such sequence. And this sequence here is will be followed by the machine. So the machine will not execute address, block number 30, unless it's already execute block number 20. Not to go for 40 unless already finished 30, and not go for 50 unless finished with 40 and so on. So this is the sequence here, and the others here, this one word for the line. For example, this is one word G28, this is coordinate X, Y, Z, and so on. So each one of this one, we call it word. So this is word, this one is word, this one is word, this is word, this word. A combination of word, it gives you one block. So if we have this type of the block, this type of the code for NC machine, for example, N080, G01, Z0 negative 0.5, F40, if you have such code or such line of code, so we need to define it. So the whole code here, we call it block. Then if we want word, example of the word is like G01. So this is word, this another word, this another word. If you want address, the letter G, we call it address. Okay, so block consists of words, words consist of address. Okay, so each word here, it has address, which is G, Z, F, N plus a number. Okay, so G is the address, F is the address, Z is the address, N is the address. The number after them is represent numbering. Okay, so to differentiate between G01, G02, G03, each G here has its own, each G with a number, it has its own definition or its explanation. For that, we say this is low-level language. The machine understands this code, but for programmer, they need to use the list of coding, the list to explain what we mean by G01, what we mean by G02, and so on. So there are actually four types of the main method that will be used for NC part programming. The first method, they call it manual part programming. So the programmer will develop the program manually from scratch. He will read the drawings, then he will write the program. That was the thing that we are going to do in this during this chapter. Okay, so you have drawing. So from this drawing, you are going to write the code from this drawing. So we call it manual part programming. The second one is computer assisted part programming. So it's not only the programmer who developed the code, but the computer and some software in the computer will be used to help to develop this program or to generate this NC part programming. This is the second type. The most commonly used part nowadays is the CAD/CAM programming. So the CAD part programming, by using CAD/CAM, the designer will create the 2D drawings. So they will make the drawings for the product by using 2D. Okay, they define the dimension, they define the tolerance, they define where is the circle, where is the hole, what is the diameter, and so on. After they complete this sketch or these drawings, the computer, by using some powerful software like Vision 360 or solid, some of the solid programs will be used as solid program to create or to convert these drawings into coding. So it will directly, if you go, I mean, there is some tools or package come with this software of Autodesk, for example, which is one of the main developers for this program, for example, for Fusion 360. So there is some package you need to add to the software, and this software will convert these drawings directly into a list of commands like G01, G03, G0, whatever is based on this drawing. It will generate the code. Then this code will be, or this program or this computer with the software will connect it to the MCU or the machine control unit, and it will send the program into MCU or machine control unit. Okay, so this is actually the most, I mean, one of the most common one for the modern machine or the modern CNC machines. So the designer no need to have two steps. I mean, one make the design, the other write the program. No. After you complete the design, the computer itself will generate the code for you. So this code will be fed to the machine, and the machine will perform the task which is required. Okay. Then the last part, the last step, which is manual data input. So this will be entered manually to the MCU or to the NC machines using the existing I mean, the existing keypad or the existing or the attached computer to the CNC machines. So if we start with the manual part programming here, we are going to see how or what are the codes that we are going to use with manual part programming, how to write the program, how to convert the drawings into coding, and so on, without the assistance of a computer and without the assistance of CAD or CAM assistant. Okay. So in order to be able to create the program, these are the things that we need to have that we already mentioned before. So knowledge about the various manufacture process of the machine. So we need to know what machines will be used to produce this product and what is the sequence of operation to be performed. And also cutting parameters or cutting tools here. They mean all about also information about the coordinate, dimensions, and so on. Editing the part program according to the design change. So if you, according to the drawing that you have, you are going to edit and change the program when you write the manual part program. But in the case of the computer assisted or in the case of the CAD/CAM, any modification will be performed. For example, for the CAD/CAM, the modification will be performed on the drawing itself. Then it will be or it will be used to generate the new code or the modified code. But for the manual part program, if you have any modification, you need to do this modification by yourself according to the design that will be changed or example, change the coordinate from 5 to 6, change from absolute to incremental, change from point to point to continuous, and so on. So all this will be reflected into the program manually. Okay. Knowledge about the code and the function used in the part program. So you need to know about the G code and N code, and each one, which code we need to use in our program according to the produced or the product that we want to produce. So usually the NC here use a combination of binary and decimal numbers. So they call the binary coded decimal, or BCD. I think you have such similar thing when you study the logic design. If not, so it's just easy is to convert. I mean, you should know how to convert from binary to decimal and from decimal to binary, because as we said before, the MCU or the machine control unit, it does not understand any command which is not in the form of digital or binary. So the machines or the MCU, whatever is the input command here to the MCU, even its letter or number and so on, it will need to be converted into a binary digit. So it will be 0, 1, 0, 0, like this one. So it's like binary digit. So usually the controller only can understand the binary digits 0, 1, 0, 1. So there is some converter which is used to convert from binary to, from decimal to binary, or from analog to digital signal and so on. So this signal will be go as in the form of a train of bits into the microprocessor unit of the controller. Okay. So each of the 10 digits, what is the idea of the BCD or binary coded decimal here? We can see by this used by RS274D G code. This is the name of the coding or the programming language that we are going to use. And the idea of the BCD here, if you have such number, which is 1250, need to convert this number into a binary number. So each part of this will be, this number will be split into different number with different level. So for example, it consists from 1000 and 250. In the first level here, we have 1000. Then in the second, we have 200. In the third, we have the 5 here represent 50. In the fourth, we have 0 here. So the total here, the sum of this value is 1250. Each of this one, for the first, means we are going to convert it into binary, which is 1 only. So the one when in decimal you want to convert into binary, it will give you 1000. Is that the one that you learn in the logic design? The 2 here, or the second lever, which is the 2, it will convert it into 02, because this is 2 to the power of 0, 2 to the power. If you want to convert this one, for example here, this is equal to 0, 1 times 2 to the power of 0 plus 0 times 2 to the power of 1 plus 0 times 2 to the power of 2 plus 0 times 2 to the power of 3. All these are zeros. Here you have 1 times 2 to the power of 0, which is 1. So for that we have this is 1. How to convert this one decimal value into digit number. You can use also your calculator, easy to convert 1 from decimal into binary with 4 bits. So it will give you this number 1. 2 will be like, this is 2 to the power of 0. This is 2 to the power of 1. This is 2 to the power of 2. This is 2 to the power of 3. So this 2 to the power of 0 times 0, it will be 0. 2 to the power of 1 times 1, it will be 2. 2 to the power of 2, which is 4, times 0, it will be 0. 2 to the power of 3, which is 8, times 0, it will be 0. So here you have 2 only, so this is the second. The third and the fourth are the same. So the idea here, how to convert this type of decimal values, For that, they call it binary coded decimal, in only to represent each part of the code from a numbers into letters. Okay. So here is the table that show you what is the value for 0, it is 0, 1, it is 1, this is 2, 3, 4, 5, 6, 7, 8, 9. So each number from 0 to 9 can be represented by a specific number of binary digits. And this is only how the code that we are going to develop will be sent to the to the controller or to the MCU or to the machine controlling. We are not going to do any calculation about this part. We are not going to perform any conversion for decimal to binary and so on. No, our focus is not on this type of logic design issue. We are going only to focus on how to write the code, and actually how this could go to the microcontroller. This will be something inside the MCU itself. Okay, but this to show you how this conversion is done in order to allow the controller to understand the feeding code into the CPU. So the manual part programming here, if we go in the detail of the manual part programming, so as we already mentioned, it consists from blocks, and each block consists from words, okay, and each word include address plus numbers, okay, block, words, and each word consists from address from a plus number. We are going to see the list of words and the list of address and so on, all in this chapter actually. So here, this is the parameter that we are going to cover. We are going to learn how to know about all these things in this chapter. So if something we already covered, for example, like this one, we know what is the difference between absolute and incremental. We already learned before, but we are going to see how to use the code to program absolute and how to use the code to program incremental. Axis designation here is more on the number of the axis designation and also the type of the movement. Is it continuous or point to point? Also the NC word here, block of information, type of the code that we are going to see, type of the code which is G code and M codes, type of programming format which is word address, tab sequence, fixed blocks, the three type of the format here. Machine tool, 0 to point, and this one, the definition we already mentioned in chapter 2 also, how to define the reference point, how to define the 0 point for the machine, the 0 point for the product, the 0 point of the general reference point for the whole operation. Coordinate word, parameter, and circle interpolation. We are going to go one by one, all of these fundamental elements that needed by to develop the manual part program. So these are the fundamental elements that we need to develop a manual part program. Each part will be, it has its own code. So we have a list of code actually, and this list of code you need, by practice, you are going to learn which code you need to use. Which letter you need to use, which number you need to use, and so on. So this is the basic, the standard or the basic standard programming format. There are three main standard for programming format. Our focus will be on the first type, which is the word address format. There is other two types, and so depends on the machine actually, because some machine, for example, are used word address format, some use the tab sequence format or fixed block format. The difference you can see here is clear by using the number, the letters. So for the word address format, always we have a letter here. There is N, G, X, Y, F, S, T, and so on. And each one, it has its own meaning. While in the subsequence here, and the tab subsequence, we have the tab value here for the greater value, which split between the different numbers. And here we have only fixed block, which consists from numbers only. You can see only numbers. So our focus will be on the first type, which is use the number with the, the letter with the number. And this we call it word address format. So this is the NC word address format. This is example for one line code by using word address format developed by this programming language, which is RS274D. Okay, so as you can see here, this is the block which start from this point until that point. So this is one line of the code or one block. What are the main part of this block, or what is this block consist of? You can see the first one, we said the sequence. So this is, we call it sequence number. So this is number 3. So that means either we are in the number 3 sequence, in the line number 3, or you may start from N5, you may start from N10. It depends on what sequence you are going to use. For example, if I want to use this one number, line number 1, maybe number 2, I am going to use N6. So that means I increase just 3. I can start from, I bought the N1 is N10, line 2 will be N20, N30, and so on. So it depends on which more convenience for the programmer to use. But the main, if the word start with the address N, so this represents sequence number. Second, the second word is start from G. So this is preparatory function. So the preparatory function here, which is start with the letter G. So there are a list or a table of different G that we are going to use. G2, G3, G20, G20, I mean 28, G2, 90, 89, 17, 16, 18, whatever is the number here. When you change the number, the commands will be changed. But now in this word, the address is G and the number is 2. If the address is G, the number is 3. Address is G, the number is 5, and so on. So it depends on what is the number, so we can understand this preparatory function used for what. Is it for moving? Is it for cutting? Is it for, depends on what is the action will be required. Then we have here X. So this X and Y and Z are address. X is for X coordinate, Y for Y axis coordinate, Z is for Z axis coordinate. So all the three here are coordinates, and the numbers after them represent the values of each axis. So I'm going to move 1.4 on the X axis, 1.4 on the Y axis, 1.4 on the Z axis, for example. So this will give you the coordinates or the destination coordinates. Then we have IJK that we already mentioned before for the extra axis or extra axis that we use with the NC machines. So this represents here the distance to the center of the circle. So when you use circle, you are going to move in a circle or in a arc here. So in the arc or the circle, there is the distance here depends on the value of r or the radius or the diameter, like we mentioned before in chapter 2. So it represents what is the dimension, the distance of the radius from the x-axis, what is the distance of the radius from the y-axis, what is the distance of the radius from the z-axis. So this also more on the same coordinates. It's related to the coordinates here. Then we have F, for example. F is address here. This is what F is address, and F is related to the feed rate. Feed rate means how fast we move the product. I mean, we move the spindle of the machine to the product. So it's related to the feed rate. Later on, we are going to see how we can calculate the value of the feed rate. Then the word S here. S is for spindle speed. So it's related to the speed of rotation of the spindle here. So it can be S4, that means the speed is 4 RPM, for example, or 10 RPM, and so on. It depends on either the unit that we use to measure the speed and also the value of the speed. T4 is related to the tool. When we say T4, that means we are going to use the tool number 4. If we say T2, we are going to use the tool number 2. T1, we are going to use the tool number 1. This numbering of tools depends on the machine itself and how many tools it has. So the number here will be changed, but the letter, which is the address, is always used for the tool. M, it is for miscellaneous functions, so it can be used for start the program, stop the program, and so on, open the coolant, close on the coolant, off the coolant, and so on. So it's used for different functions. Usually this is the sequence for the line or the one line or the one block format. Always we start with the number, then we have G, then we have the coordinates, then if we have a circle or arc, we are going to use IJK. After that, if we have feed rate, we are going to include after that, then the speed, then the type of the tool, then the M values. Okay, so the order, it will be in this form for one line. It's not important to have all these parameters in one line. Maybe you have only N3 and G and X, for example. Others all not there. It's okay. I mean, it depends on what is the task that required by the machine. Do you need to have spindle speed? Do you need to have feed rate? Do you need to have to change the type of the tool and so on? It depends on the task that the machine need to perform. Okay. This is also another representation for the, I mean, to show how the block looks like. As same is a sequence, preparatory function here, dimension X, Y, and also we have this is a shorter block. As we told you, it's not necessary to have all this address. You may have only 2, you may have 3, you may have 4, depends on the drawing that you have. So, and the function that you need to perform, the machine need to perform. Okay. So also the same here is the definition for this is the sequence, this is the for linear interpolation, because we have already number here G01. So G01 represent the linear interpolation that we have, or there is also G02 and G03 for circular interpolation. Depends. Here is the dimension of X, here is the dimension of Y or the coordinates. Here M03 is represent, for example, spindle on clockwise. That means the spindle will be rotated with clockwise direction, and you have here the semicolon for the end of the program.